Sampling size in experiment. Generally, it is easy to overlook the estimate of sampling size during the design of experiment. This is because many people do not understand the statistical content of statistical power and experiment. Therefore, I will explain the concept of statistical power in this presentation and show the process of obtaining a reasonable sample size by actually referring to article published in the Korea Journal of Veterinary Medicine. Our project consists of three parts. First, background. Second, survival report. Last, experiment. In the hypothesis test, researcher assumed nerve hypothesis and alternative hypothesis. Reject hypothesis as neural hypothesis is valid or invalid. Type 1 and type 2 error appears at this time. The probability of rejecting a neural hypothesis when it is wrong is called sensitivity, power, same as power. This is statistical power. A type 1 error occurs when the neural hypothesis is true but is rejected, and a type 2 error occurred when the neural hypothesis is first but analysis first to be rejected. So statistical power is important to prevent type 2 error. Generally, if you have a power of 0.8 or more, you can think of it as reasonable statistical result. We can design our new experiment by studying similar previous paper. We called this process post-hoc power analysis. If we jump over this step and get unsatisfied statistical power, we can turn it back. We cannot turn it back. So we have to estimate power before start experiment. Before having statistical power, we should know about sample size and effect size and significant level. And then we can calculate statistical power by using G program. Before our project, we study about ANOVA and vectoring influence power and G power. In the last semester, we surveyed the statistical technique and experimental animals used in the veterinary survival for past 4 years. Among them, ANOVA and student t-test were the most common. In this experiment, we use ANOVA test. Factors influencing the power or sample size, significant level, and effect size. I want to explain them properly. First, sample size is the total number of samples used in the experiment. If the sample size is large, the accuracy and statistical power of the experiment will increase, but the cost for the experiment will also increase. So it is important to obtain appropriate sample size by using minimal cost. Significant level up is the error probability of the sample statistical obtaining from the sample. When the hypothesis test is performed, the power value increases as the p-value becomes smaller. If the p-value is greater than 0.05, the power dropped unreasonably. Effect size means the extent of size in the population or the degree to which the null hypothesis is wrong, and it can be obtained by dividing the subtraction of the experiment group in the control group by variancing value of the experiment group. G-power is a tool to compute statistical power analysis for many different tests. In this experiment, we can use this program to calculate power and sample size. In order to obtain the proper sample size in the course of experiment design, the post-hoc power analysis is used to find out whether the power in the preceding research is appropriate. After that course, the pre-pro power analysis is performed to use the effect size of preceding study to obtaining the minimum sample size, start filing, and the power can be obtained. Here is the paper listed in Korea Journal of Veterinary Medicine. For example, as mentioned earlier, three factors can be obtained through post-hook analysis, and the power of the previous research can be confirmed to be 0.8 or more. Then we set the significant level to 0.05, set the power to 0.8, add the effect size obtaining from the post-hook analysis, and perform the prepare power analysis to obtaining the appropriate number of samples. It is the post-hook power analysis. We took the previous value as an example and obtaining a power of about 0.84, which was more than 8% power. Now, if we take a sample of power 0.8 and the significant level alpha of the 0.05 using the appropriate power analyzing effect size, which is the process of designing the lab, we should know that you should use at least 38 samples. Thank you.